Okay, let's keep going. It's getting late, but I just want to get this done. So to find the value of the angle theta, we just need to use inverse tan, inverse cos to get the angle. Okay, that's all you got to do. So let's just try a couple. So like the first one. Oh, the first one actually is a bit tricky, but I guess that's why we should do it. So I'm going to do inverse sine of 0.5294. I'll show you why it's tricky. Okay, so if I do this is just to simulate what you should get. So you should get 31. Now the problem is 31 degrees or 32 is not an obtuse angle, right? It's less than 90. So the rule though is you just do 180, take away that amount. Okay, so maybe if you're looking for an obtuse angle but you get an acute one, just do 180 minus it. Okay, for whatever reason. It's a little tricky to explain. That's closest to 32, so we'll do 180 take away. Oh, sorry, I should just write 32. What's it doing? Okay, so then, well, I guess let's not write theta equals that. That equals 32, but then theta is 180 minus 32, which is 148 degrees. Okay, this one shouldn't be so bad. If I do like, say, cos, let's try that one. It's just a thing with sine, it's a little bit annoying. Oh wait, convert it to degrees. Okay, minus 0.2621. Cool, so notice that's already obtuse, so we didn't need to do anything. So theta equals inverse cos, hang on, of minus 0.2621, which equals, so we'll say 105 degrees, nearest degree. Okay? Alright, I'm going to move on from that. You just use your calculator. The length of the unknown side. So there's going to be either sine rule or cosine rule. So remember, cosine rule involves all three sides. I think these are all the sine rule. I can tell because there's a side missing in each case. So let's just do the second one. X goes with the 109 and 32 degrees goes with the 6.1. Okay, so we're going to do x over, always start with what you're looking for, over sine 109 degrees equals the other side, so 6.1 over the other angle, so opposite it. Cool, and then we need to get rid of the sine 109. I'm going to throw it up here on the top. I don't want to put it before, I'd like to put it after the 6.1 because it's actually less confusing. I'll show you. So let's just do, what is it doing? Okay, let's just do that, sine 32 degrees, whatever. So now if I put it here, the problem is sometimes on your calculator you'll write, actually I'll just write it out, 109. If you don't remember to put the brackets in, you can end up timesing 109 by 6.1 by mistake, and you don't want to do that. So it just tends to be better to put it after, like that. Okay, but whatever that equals. So let's figure that out. And it's a length that we're finding, so there's no units though, so that's fine. 2 decimal places. Alright, so 6.1 times sine 109 over sine 32. 10.88. Okay. The next decimal is a 4, so that's fine. Alright, I'm not going to do the others, they're the same. This one, I think we need cosine rule. And again, we need two sides with an angle in between them. Okay? Two sides and angle in between. Let's do the third one, doesn't really matter. Okay, it's very similar to Pythagoras' theorem. So x squared is 2.5 squared plus 3.1 squared minus 2 times that times that. Don't forget there's a formula sheet. Maybe I should just, let's see, let's find where these are. Okay, these sorts of things. So I use that one a bit. This is the one I'm using right now. If you're finding an angle with the cosine rule, you use this one, which is just, these are just rearranged. It's so easy algebra, and it's so powerful once you get it. You can just take that and easily figure out this thing. They're the same relationship. Just like if I'm 5 centimeters taller than someone, then they're 5 centimeters shorter than me. It's the same formula. This is the sine rule. Okay, cool. And so you'll have all that in the exam. Alright. Okay, yep. And then, oh, sorry, I forgot cos. So let's say cos 96 degrees. Yep. Look, if you want, you can put times. But anyway. Alright, so 2.5 squared plus 3.1 squared plus 2 times 2 times 2.1 times cos 96. Okay, don't forget we need to square root it. So in fact, where did I write it poorly the other time? I'm going to square root that straight away. So whatever that is, square root it. So 4.18. I'm guessing it's 2 decimals. Yeah, 2 decimals, no units. Still finding a length. Just seeing if, oh, I guess that one I didn't write the answer. But yeah, just remember whenever you're figuring it out, try to square root it. And try to make it so your lines make sense. Because if you write that equals 4.18, it's not right. It's x equals that. X squared is that. So anyway, I don't know if that makes sense. Alright, last ones. Let's do these two because they look important. So this is a right angle. We've got that angle. We've got that length. We've got that angle. Okay, find the length of BD. Okay, so I'm thinking of this triangle. We're going to use triangles each time. I'm thinking the sine rule. This side is opposite this angle, and this side is opposite this angle. But we can get this angle from these two. Okay, so first thing we're going to do, 180 take away 24 and 29, which makes 40 plus 30, 53. Okay, 127 degrees goes here. I want this x. I'm going to call this x or BD. I can leave it as BD. I'll call it BD. So BD, that length over sine 24, is the same as the length of 20 over sine 127 degrees. Because it's opposite. Okay? This sine 24 I need to put up here. Okay, so BD is 20. I'm going to just write this first. And then, yeah, next to this 20, put the sine 24 degrees. Okay? If I want, I can put a times there. Doesn't matter. Alright, let's figure it out. 20 times sine 24 over sine 127. So 10.19. Yep, 2 decimals. Come on, come on. Okay, equals 10.19 meters. Okay, about 10.2 meters. Alright. Find the size of angle BDC. That's easy. This angle, we already know this is 127. So we just do 180 take away 127, which is 53 degrees. Cool. That's this angle. The nearest, am I confused here? What's going on? BDC. Nearest minute? What are they talking about? I think that's a joke. Find the length of CD. Okay, so in this triangle now, this right angle triangle, I know this angle and I know this length BD. So I'm going to call, well, I guess I could call it CD. But anyway, it's going to be adjacent and hypotenuse relative to this angle. Okay? So just imagine 53 degrees is here. We know this length is 10.19. and so adjacent, hypotenuse, so cos. So let's do it. Hopefully it'll make sense to you. Cos 53 degrees has to equal CD or DC. I'll just write CD over that length BD, but I'm going to write 10.19 because we know that length. So to get CD by itself, we need to times by 10.19. So CD is 10.19. I'll just write times, doesn't matter, cos 53. Okay, and then whatever that equals. So let's do it. 10.19 times cos 53. 6.13. And that should be meters as well. So this is 20 meters, this is 10.19, and this is 6.13. Okay, it's not to scale, but that's the answer. Okay, radial survey. So we've got north. These are the true bearings for these directions. So this is northwest, sort of southeast, I guess. So A, O, B. A is here, then O, then B. So it's this angle down here. This is actually really easy to get. We just need to see from there how far clockwise did it turn. So these angles are all we need. We just need to figure out the difference. So subtract. So let's do 256 minus 108, which is 148. I'm getting tired. It's past my bedtime. Degrees. What is it doing? Okay. 148 degrees. That's the answer. The area of AOB. Okay, so I know the angle here and I know the two side lengths, 7 and B. I'm assuming meters. I don't think it mentioned. Okay, so the area is half AB sine C. Okay, so half times, so the two lengths we're looking at are 5 and 7. So 5 times 7, and then it's important the angle in between them. Where was it? 148, I think. So 148 degrees. Okay, whatever that equals. So 0.5 times 5 times 7 sine 148. 9.27 square meters, or meters squared, either way. Alright. Okay, what is the length? Oh, to the nearest square meter is just 9. Okay, whatever. You can just write both of them. I don't know why they want it. That's really rough. I hope I did it right. That's a pretty small number, but that's quite an obtuse angle, so that's why there's not that much area. I'm pretty sure that's right. Okay, what is the length of AB? AB, okay, easy again. It's the cosine rule. We've got the angle, we've got two sides, and we need to find the other side. So, it's the same as what we did earlier. I can again call it AB if I want. AB squared has to be 5 squared plus 7 squared minus 2 times 5 times 7 times the cos of 148 degrees. Okay, and then whatever that is, I'll square root to get AB. So I'm going to do 25 plus 49 minus, so 10 times 7 will be 70. I'm just taking some shortcuts, but it's the same thing. That number, and then I'm going to square root it. You can do this all in one step. I'll just try to show you. So 11.55. What did it say? To the nearest meter will be 12 meters. Okay. I'm just doing it to 2 decimals. Let me check, did I round? Yep, but anyway, they want nearest meters, so 12 meters. I just want to show you, if you want to write this differently, instead of putting the squared there, you can just put a giant, hope this works, over here, just a huge square root outside of it. let's see, maybe I can, like that. Okay, that's also fine. I mean, that's the same. That's what we're actually doing. As long as either it's one or the other. AB squared equals this stuff without the square root, or AB equals the square root of all that stuff. Anyway, I hope that helped. I'll leave it there. Thanks for watching. Bye.